Welcome everyone. Day 208, I think. Day 208, I'm not sure. So we're on a decent streak with LeetCode. It's pretty good. 208. So that's nice. 208. I know there's been a lot of LeetCode lately, but still in my internship. I'm actually gonna be ending my internship pretty soon. I'll be done by next week, so we'll be back to my actual house, and maybe we'll start some kind of project, but I don't know exactly. So in the meantime, I'll be practicing problems, because it's also I need to also get ready for the next application cycle. But anyways, let's do this. I did some studying for topological sort, and I'm gonna see if I can apply it for this, because I know this is a problem that you can use topological sort. So let's see. So you're given a total of n courses you have to take from labeled 0 to n minus. You're given a prerequisite where prerequisites of A, B indicates that you must take a Yep. Return the ordering of courses you should take first. If there are many valid ones, return any of them if it's possible. So yeah, this is 100% the topo sort. So first, let's construct our graph, right? For every course prerequisites graph of, actually we should do it default dict and graph of the course and the prerequisites that exist, right? So we have our thing here, right? Then topo sort is essentially topo sort is DFS and reverse the list. Return list, right? Right. List in return DFS would traverse the graph. Traverse the graph using DFS. Return the reverse order of it. So like, it's not that bad. So let's first figure out the DFS. So df. Well, actually, I'll do that. I guess we can say course here, and we'll write that a little bit later. And then the setup for this is stack, or I guess courses, right? For every I course in range of num courses, right? We call DFS, right? We also have a scene here. If course in scene, so if course in scene, then scene dot add course, right? Oh no. If course in the scene, then or I guess not in scene, then DFS the course and scene. Yeah. Actually, don't even add this. It'll be globally set. And then return courses the reverse. So again, now this is the case. So if we have already processed the thing, then if course in scene, then return, right? It's the first time we're seeing this. We of course to add to scene. Let's add this here, right? Then let's traverse its neighbors for every or in graph of course, right? Call DFS on it, which is neighbor, right? After that's processed, then courses dot append course, right? So if course in scene return course dot add scene for every neighbor in the graph course at DFS, then call DFS on that neighbor, and eventually we'll basically, this is normal DFS, right? Yeah, we're good then. Let's try that. Oh, what am I saying? If scene dot add course, why am I being weird? Right, adding the course we already seen in the set. I think there's a problem here. I think I should reset this set. So that's why I want to say set scene here, and then we'll just pass in a set all the time. Because I want to restart every time, so we could do that. So for each single starting traversal, oh yeah, that makes no sense at all. No point of checking, I guess. Something wrong here. Yeah, okay, I have an idea. I think there's a problem with my DFS. So my issue right now is we have this here, right? We want to do courses. I don't know. Okay, so we're doing DFS. We added to set. Graph course dot append pre. Okay, okay. First, my base case is kind of messed up. All right. Do we have a global course, or like, okay, we need to make a courses. That's just mandatory, right? Courses, right? And then we're gonna be adding to the course. Let me just print. I don't know. Let's print courses at the end first. Print course. Wait, we have no scene. Hold on. Let's have a global set. So scene here. We have the set here. I guess if course in scene, not in scene. I have that here. What now? Oh, we have a bad base case. If course in scene, let's not process it at all. Return. So how does that sound? Oh wait, we don't need this at all. Alright, what am I doing wrong? So the output is 1 0. Maybe I'm not supposed to reverse it? What? Oh, no. Core says. That's weird. Why? I thought we were supposed to reverse them. Alright, let's see this one. Submission. So we got an output of 1 0. Ooh, I need to detect cycles too. I forgot about that. Yeah, that's a problem. This is not possible. How do we detect cycles? I guess else return this. I guess like that, because every node we check shouldn't be like that, I guess. That's a little bit suspicious. A little better this time, but now we have a problem with this. Oh. Okay, so we have a fundamental issue. Okay, let's break down why this doesn't make sense. We have a bunch of courses. Right. So my problem is it's not doing cycle detection. That's why. But remember the last problem we had like state. So we can have like, instead of a scene state, we can just call it on everyone, right? Do this as well. And have like these going on, right? Times courses, right? Basically, instead of doing, so if state of course equals 1, then we could do like a self.has cycle. False, and then we'll do self.has cycle true, because that's not what we want, right? If state of course equals 2, then return. That's fine. So first mark it as state course 1, because once we chose in our children, if we end up going back to this, then that's bad, and we'll, you have to accordingly adjust. But once that's done, then we're in a good state, so we can mark it as seen by number 2. That was a pattern we did last time. And then after that, we just append that to our course, and then for every course in then call DFS. Yeah. outpost that. Okay, wait, what's the oh wait, I have an idea. So we have to do this. If self dot has a cycle, then return an empty list. Right, that's what we want, right? Yeah. Oh, nice. Pretty nice. Alright. Thanks for watching. I'll see you guys tomorrow. Peace.